Good morning, students. Today we'll start with the next topic. So all of you keep your pens, notebooks ready. And the topic for today is refractive index. Okay, the topic for today is refractive index. So let's start the topic, dear. I hope you're familiar with this diagram. You've done this diagram earlier also, right? This is your normal ray. This is your line of interface, above which you have first medium, below which you have second medium. In medium 1, the speed of light is v1. In medium 2, the speed of light is v2. This is your incident ray. When incident ray falls at the point O, it makes an angle with the normal ray, and that angle is called angle of incidence, right? And what does this dotted line indicate? This dotted line indicates that the light was to travel in this way. Light को इस तरीके से travel करना था. So we refer it as the original path of light. So what does this line indicates? The original path of light. But light is going in this way, right? So this is your refracted ray. And the angle between the normal ray and the refracted ray is angle R. So angle I is your angle of incidence. Angle R is your angle of refraction. Now students, I hope you also remember the Snell's law. Do you remember Snell's law? What was it? That sin I upon sin R is equal to a constant. Do you remember? Sin I upon sin R is equal to a constant. And this constant is called refractive index. Okay, and this constant is called the refractive index. Clear? So we'll talk about how to calculate this refractive index. Now remember, the medium 1, the medium 2, here the speed is v1, here the speed is v2. We will use this v1 and v2. Okay, and we can easily calculate the refractive index of medium 1 or medium 2, whichever we want, right? Now suppose if I want to calculate the refractive index of medium 1, मुझे किसका रिफ्रैक्टिव इंडेक्स निकालना है? मीडियम 1 का रिफ्रैक्टिव इंडेक्स निकालना है. ठीक है? जब मैं मीडियम 1 का रिफ्रैक्टिव इंडेक्स निकाल रही हूँ, सो मुझे इसे रिफ्रैक्टिव इंडेक्स को मीडियम 2 से कंपेयर करना है, राइट? मीन्स आई एम कैलकुलेटिंग द रिफ्रैक्टिव इंडेक्स ऑफ 1, but I have to compare it with the medium 2. So I will use the symbol N12. Right? I'll use the symbol N12. 1 means I am calculating for first medium. And I am comparing it with second medium. Are you getting my point? If it is not clear, I am repeating it again. Right? This is very, very important one. Because on this, the complete lecture will depend. So when I will write N12, जब मैं फर्स्ट मीडियम का रिफ्रैक्टिव इंडेक्स कैलकुलेट कर रही हूँ, ठीक है? किसके कंपैरिजन में? मीडियम 2 के कंपैरिजन में, राइट? So I'll write N12. Second way is, if I'm calculating for medium 2 and I'm comparing it with medium 1, so then I will write N21. N21 means I'm calculating for medium 2 and I'm comparing it with medium 1. Right? So we'll calculate these two values. Okay? Let's see how we can calculate these two values. N21. Just now we've discussed N21. Okay? So N21 will be, we'll write the speed of light in medium 1. Okay? First, we'll write the speed of medium 1 and then we'll write speed of medium 2. So N21 will be equal to V1 upon V2. Yes, dear students? Okay. So when I'm calculating the refractive index of medium 2. Okay, when I'm calculating the refractive index of medium 2, I'll write V1 on the top and then below it we'll write V2. Okay, then N12. I'm calculating the refractive index of medium 1. Okay, medium 1. So I'll write speed of light in medium 2 first. And speed of light in medium 1. So N12 will be equal to V2 upon V1. I hope you're getting the difference. Are you getting the difference? Yes. So N21 is equal to V1 upon V2. And N12 is equal to V2 upon V1. So this is the way we can calculate the refractive index of two mediums. Okay. And since we are comparing these two media, right, we are comparing these two media, we call this refractive index as relative refractive index. Okay. So what is relative refractive index? It is the ratio of speed of light in one medium, okay, in comparison to second medium. Okay. What is relative refractive index? It is the ratio of speed of light in medium 1 upon the speed of light in medium 2. So if you are asked to define relative refractive index, you will write this definition and you will write any one of this formula. Okay. Now one more important thing, N12 will be equal to 1 by N21. Okay, this is again very important one. N12 will always be equal to 1 upon N21, right? Okay, let's go to the next slide. Absolute refractive index. Just now we discussed relative refractive index. Okay, now we'll talk about the absolute refractive index. This is also simply called as relative index, refractive index, sorry. Right? We call it as absolute refractive index, and we also call it as simply refractive index also. So if you are asked what is refractive index, you will also write the same. And if you are asked absolute refractive index, again same. Now this relative refractive index, the absolute refractive index is denoted by Nm. You got to write it by this way, Nm. Okay? And this Nm will be equal to speed of light in air in comparison to the speed of light in medium. Now very important. In case of relative, we had two medium 1, medium 2. But in case of absolute refractive index, one medium will always be air. One medium will always be air. It is the second medium which will be changing. Air will always be there, right? So Nm can also be written as C by V. So what is the formula of refractive index? C by V. If we know, C की वैल्यू हमें हमेशा पता होगी, and that is C is equal to 3 into 10 to the power 8 meter per second. This is the speed of light in air or in vacuum. Okay, speed of light in air, speed of light in vacuum, right? This will always, you should remember, you should learn this value, so you will always know the speed of light in air. Now you're left with two things, Nm and V. If we know any one of them, either Nm is given or V is given, so we can easily calculate, because out of the three values, two we know. Okay, if we know V, we will put the values and we can calculate Nm. And if we know the Nm, we can calculate the speed of light in the medium. Okay, right. So refractive index of two medium. I'm just comparing the two medium. I've taken air and water here. Air has 1.003. The refractive index in air is this, and the refractive index of water is this. Which one has a more refractive index? Water. Yes? Water. Right? So this is your denser medium. And air has lesser, so this is your rarer medium. Okay? So we can say if Nm is more, the optical density is more. If Nm is less, the optical density is less. अगर हमारी Nm की वैल्यू ज़्यादा है, यानी हमारा रिफ्रैक्टिव इंडेक्स ज़्यादा है, तो ऑप्टिकल डेंसिटी भी ज़्यादा है. अगर हमारा रिफ्रैक्टिव इंडेक्स कम है, तो ऑप्टिकल डेंसिटी भी कम है. But always remember, when optical density is less, then speed of light is more. अब देखिए एयर जो है वहां पर Nm की वैल्यू कम है, लेकिन यहाँ पर स्पीड ऑफ लाइट इज मोर. Okay, the speed of light is more. Okay. Now can we come to the your homework for today, if you're done with this? Okay. Now let's discuss one part more. This is the table which is given in your book. You must go through it, where refractive index of you can say different medium are given. In air 1.03, just now we've discussed. In ice 1.13, water, right, in this way. Then crown glass 1.52, diamond it is 2.42. So if we go through the table, we find the refractive index of diamond is highest, right? The refractive index of diamond is highest. This means the speed of light will be minimum in diamond. Okay, and speed of light will be maximum in air, because air has the least refractive index. Okay, so you can be asked to calculate, you can say refractive index based on this table also, or you can be given the values in the numerical. You can be asked to calculate, right? So this table is very much important. Now coming to your homework, first of all, again you will make the notes of the topic as we usually have. Second, you will read the page numbers 174 to 175, and then you will complete the 3 questions on page 176, that is question number 2, 3 and 4, right? You will complete the homework and will send the homework to me. Okay, dear students? Right. Okay. Bye everyone.